Hi everybody, I'm Walt Lewis and we're here with another Fire Engineering Training Minutes. I got my friend Jason Revoldt out again today to help me out talking about UAV systems and what we can do for best practices for applying them to our fire ground and other emergency scenes. Some of the things that have been valuable to me, Jay, is of course when we read the manufacturer's instructions and go by some of the training programs that are out there, is we want to make sure our device starts off with full power. We got my view screen, in this case it's my iPhone, but there are much bigger screens that are better and also compatible to utilize, but make sure that you got full power so nothing fails on you at a critical time, right?
Right.
And then make sure we have the proper application that's going to be in use with the device we have. So whatever device we're using, whether it be this or another one that's on the market, these are all going to be common best practices.
Right.
Having that full power, aside from the device and the screen and the controller, what are some of the things that you want to make sure that you have going?
So most of these they're based off the same type of airframe. You have propellers, you have a body, and you have landing gear. You want to make sure that, one, your propellers are on tight. You want to make sure that all the propellers are smooth, there's no nicks, no scratches and stuff like that. You want to check the airframe. You want to make sure there's no cracks, stress cracks or anything like that. Make sure that your battery is secured well in flight. Make sure that your landing gear is good and that your camera is operating and looking fine. The whole purpose of this is to get some good aerial photography, and if our camera is not working, it's kind of a waste of a flight.
Some of the other steps we want to take when we fly our device is make sure we got a safe area to fly. We don't want high tension power lines or a risk of population immediately around us.
One other thing too is we're really lucky today. We're a great day to fly, but you want to check your weather. You want to know what your winds are like. You want to know if you're going to be expecting any kind of rains. These devices are not particularly fond of rain, so we want to make sure that all the systems that we can be in control of are addressed.
Now you mentioned winds. In the USAR environment, hurricanes and tornadoes are very prominent, and they cause a lot of the USAR environments that we have to deal with. And when I want to launch my device, it's not uncommon after a hurricane that we still have some pretty strong winds. What do most manufacturers recommend as a high wind issue?
It all depends on the manufacturer. These are pretty stable platforms, and they can compensate for a good majority of winds. From what I've read a little bit on the DJI, around 35 miles per hour, that's kind of your threshold. You don't really want to push it, and you want to be as well into a low wind situation as you can.
Gotcha.
But every device is going to be different.
Of course, you certainly want to consult the manufacturer's suggestions. But definitely with the wind, the harder the motor's got to work, the longer or the shorter the time you're going to have for flying.
Right, that's going to eat up your battery.
So
yes.
Battery life is going to be one of those things. And of course, that's the most critical component, is starting off with full battery life. So in this case here, we're going to fire up the device, do a quick test for the flight to make sure it's safe, and then get into our procedure. Okay, we've acquired the Wi-Fi connection to our device. I've got my screen on, my battery's on, everything's on for my controller. I'm ready to fly, kind of. I still have a couple steps, right?
Right. So you want to make sure that your takeoff area is good. You're going to get some information. There's data going back and forth between your controller and the UAS itself. And one of the things it's trying to do, it's trying to warm up, it's trying to make sure its compasses are correct. And with compasses, they're very
susceptible to metal, right?
Correct, ferrous metal. And with this situation that we're in, and a lot of places in the urban setting, you got concrete. And this concrete pad here has got rebar running through it. So you might come up with an error on your system, and it's going to have a hard time calibrating the compass. So you want to take it off into a grassy area, just away from metal buildings, metal vehicles, and then the metal rebar that's in that concrete.
Gotcha. Well, I certainly want to make sure I have my satellite acquisition, because my come to home feature that's on almost every device out there allows me to bring this device back to its GPS found location when it started up. So in case I lose connection, it comes back to where it thinks it started from. Now, if you start off on a mobile platform, say from a boat, or you go mobile once you launch, realize that device is going to go back to where it started as home. And
correct.
If your location isn't safe for it to go back to, it's still going to try and go back there unless you regain control.
Right. An additional point on that is, if for some reason during your flight you do land, some of the newer systems are going to record that as its home point.
Okay,
so be aware of
GPS. I got you.
Correct. So that makes a new home point. So usually the device will let you know that the go point has been changed, and so if you finish your flight and you hit return to home, it might go in a direction you weren't expecting. So
Man,
always be prepared for the unexpected with these.
And that's why I have you here today, to keep eyes on the device while I watch the screen. Now, certainly there's better screens out there. For my system, it's set up to use my iPhone, and that's what I have. In this case here, I also want to check my camera and make sure it's going to do what I want, and I'm going to capture the footage that I want to do. And I've got full battery power, my SD card's in place, so I don't miss out on any footage that I want, and all my features are coming up, and I don't have any warnings coming up on my screen to tell me that I can't fly here or that I have other issues with my craft or connections.
Correct.
So it seems like we're pretty good to go to launch the device and make sure it's operational.
I believe so.
All right.
One extra caveat, so trust in the device to tell you where you can and cannot fly, but also know for yourself. Do pre-planning, especially in our world. It might be a little quick, but try to know where you are able to fly and where you can't fly.
You bring up a great point. And all that pre-planning to get our system up and running, with working with our agency or city and county governments, whomever else may be involved in making sure this process can get put through. But for the confidence of our agency, we want to make sure we have all the areas that we know we can and can't fly, so that we do so safely.
Absolutely.
For sure. All right, let's bring it up in the air and see how it goes.
Will do. So as you're hovering, you're making sure that your propellers are on good, that it's controlled the way you want it to be controlled. And it gives an opportunity for the device to secure its GPS location.
I'm circulating back and forth and just testing every different direction to make sure it's all going to do what I want. I realize that I've got some wind influence on this flight, because certainly that's a factor. And in this case here, I'm ready to go. Jason, you keep an eye on the device and I'll watch the screen.
Absolutely. So as the observer, one of the things that I'm looking for are things that you're not going to see on your screen, like power lines. With my eyes, I can see that you got some power lines back there on the other side of the lake, but when you're looking through your screen, you probably can't see them. And even though some of the newer devices, they have sensors all the way around them, those sensors won't pick up tiny little things like little branches and power lines. So that's one of the important features of the observer, is to be looking out for those things that you won't see on your screen, in addition to any kind of aircraft or anything that's going to impede your flight.
Okay. Now, having my device up in the air, the view gets a little grainy, and certainly gets improved when I bring this SD card back to a computer or something else that's got better resolution.
Right. So the video that you're getting from the device right now that's going to your phone is going to be a lower resolution.
Okay.
Your highest resolution is going to be what's stored on the device itself.
All right, now as I bring it back, I've done my flight. As far as I can tell, I didn't hit anything, go anywhere I shouldn't, or cause any problems. And I just want to make sure I bring it back safely and then do some follow-up on it. All right, now we're checking out the device, make sure it had a good safe flight and we didn't incur any damage along the way. Now, if we did hit something and it continued to fly, we did risk maybe cracking a propeller or causing some body damage. And this is our time to be able to find that out, right?
Correct. So we're going to go through, just like we did in our pre-flight, we're going to go through all our blades. We're going to make sure that nothing happened that we weren't aware of during our flight. Something that we could be able to fix for our next flight. If after your flight you notice your battery compartment was loose, it's something we want to address before we make that next flight. But make sure all the propellers are on good. We have no stress cracks on the airframe. And also our landing gear is still good and intact. And our camera is good. So we know we probably had a good flight. Everything worked prior to the flight and everything worked after the flight.
Awesome. So now we can launch again. We still have some decent battery power. We can launch again, shoot some more video, take another look at a dangerous situation, whatever it is that we're using this device for, and help make our scene safer.
Yes.
But using some of these best practices will help our device get downrange, come back from this situation, and allow us to fly the device without causing any problems for the public, our agency, our personnel, or the scene. For Fire Engineering Training Minutes, I'm Walt Lewis.
And I'm Jason Revoldt.
Thanks for watching.